Remember, when you have multiple triangles, you want to focus in on the supplementary / complementary scenarios. Okay? So in this case, it guides you through it. So determine the measure of ABC, angle ABC. Where is that? A to B to C, right? So you're traveling those two sides. So those are the ones you're connecting. It's asking for this one in particular. Okay? And you should see that it is right next to another angle along this straight line here. Okay? So this angle ABC, you have to be very clear that that's what you're answering. Okay? Some students just put a number down. Make sure you say angle ABC, this one. I highlighted it, right? So that's going to be what? Some mental math, that's going to be 130, right? But if you want to show the work, there you go. That would usually be worth a mark. So right here, you've got your supplementary angle happening, right? I'm reminding you of this fact here. From end to end is 180. If you do a complete circle, it's 360. But obviously, we're not going to use that in this course. I should be careful. I feel like I could come up with something, and not right away, but later. Okay, so we've got ABC, so we can actually write that in there. That's 130. Okay, 130 degrees. And now it's also asking for angle C. That one is up top here. That's this sliver here. We expect it to be a smaller number. Okay, so angle C is 180 as well, 180, but I'm going to subtract the two angles that are inside that triangle. So don't mix it up, because some of you are thinking probably, oh, 180 minus one angle to get this one, and then 180 minus two angles to get that one. What's going on? This is inside this triangle that we're talking about. These two are right next to each other. Okay, that's why you're only subtracting one number. What do we have, 45? No. That's 165. 15? 15 degrees for this one here. Here we go. So we've got that one out of the way. So we've got angle C and we've got angle ABC. And it's important for you to be able to find them. Okay. And what's next? Calculate the height of the cliff. It wants this basically. Okay, it wants this height right here. What is that? And we know we have a 90 here. As it stands, we cannot do it. Okay, like you can't just. You don't have enough. Please pay attention to this one. Okay, you might say, well, sine of 35. Watch this. It's across this side, right? But sine of 35 is also across this side here. It is true. It is across both of them. But you don't want to mix up triangles. If you're going to say 35 over this side here, that's the one I'm going to actually focus on. I'm going to call that x. Okay. See how you're inside this triangle right here? So you need to find another pair that's going to be inside that triangle. You cannot go, oh, I'm going to go here, and then I'm going to go 130 over that. You can't mix up the triangles. So let's go sine of 35. What's our pair here, by the way? 15 is across 15. Okay? So we're going to go sine of 15 over 15 meters. And then we're going to either have to choose 130. If we choose 130, we will find this side. If we choose 35, we're going to find that side. So I'm going to choose 35 as my setup here. And that's angle X, side X. I'm going to figure out what that is. Cross multiply and divide. And if you've already done this, just bear with me. I can still teach you little things here and there. I don't have the key in front of me right now. I should have. And we are, it's 33.24. And we are in meters. And I like highlighting, right? So it's easy to see when you come back and check this. We've solved this side here that is being shared between these two triangles. And now moving in, okay, now that I have this one, I can figure it out because the sine of 90 here is across this side, the one I just found. So I'm going to go, this is the second triangle, right? This one here is my first triangle that I dealt with. So let's go sine of 90 over 33.24. And I'm going to use this 50 to figure out the height there. There. And so we're just going to cross multiply and divide. So it's 33.24 times sine of 50 divided by sine of 90. And if you remember anything from yesterday, I mentioned sine of 90 is always 1. Okay, so you just go 33.24 times sine of 50, and you get 2546. This is the ultimate. This is what we wanted, right? Running out of colors, but I do have blue here, so I'm just going to give that a color and just say that's what we wanted, right? We wanted the height of the cliff, and we found it. And this is multi-step, right? We've done two different steps there. Okay. And I took it a little further. C. Just make sure you write this down first. And it's all about knowing what side are you solving for. How far from the base of the cliff is Belinda? This is the base right here of the cliff, right? The bottom of the cliff to Belinda. So they're asking us for this side right here. And maybe it's a bit too crazy to just keep working with that one. So I'm gonna sketch this one out here. This is that second triangle here. We know this is a 90. We know that this is 33.24. We know that this 50-degree angle can come with us here. And let's call this Z, or something that you haven't used yet. Z. Z, I'm telling you, it's pretty easy. 50, if this is 90 and this is 50, we can use the sum of triangles to solve for this angle here. That one is a 40 here. This is a 40. I just went 180 minus 90 minus 50, right? Why do I want this 40? This 40 is across this side. So you need that. Okay. So I'm just going to go sine of 90 over this. Hold it. Mr. Dixon, why aren't you using, you kept on telling us in the beginning to use the same pair that you've been given. Just keep using it. I'm in a different triangle now, right? I can't be using this pair here because this one was related to this triangle out here. Okay, so I moved on. I'm no longer in that triangle. I'm now in this one. So I'm going to go sine of 90 over that. And now I'm going to use sine of 40 over z. Okay. And that's times sine of 40 divided by sine of 90. And I'll just give you the answer. That is 2137. And I know my key I used X for that one. Doesn't matter. That's how far Belinda is from the base of the cliff. What about Aiden? Aiden is just further back. It's 15 meters behind, right, Belinda? So in this case, it'd just be easiest to add these two numbers up. Okay, I'm just going to go 15 meters plus 2137, and that is 3636. 37. You could have used sine law there, but maybe let's not mix it up too much in this case. So we found heights. So heights are vertical with respect to the ground. Nothing changes. In fact, everything we've done here is just using the laws. And sine law seems to be the most popular, but don't think it's always sine law. And we're solving, one more thing here, we're solving mostly for sides using sine law, right? The angles are mostly found by using supplementary angles that are next to each other, or sum of triangle, right? So it makes it a lot easier, but don't think that that's the only thing we will ever do, okay? We will use sine law to actually figure out the angle when it's missing, okay? There's one example I just realized that I don't have enough of. It's gonna come up later. I just wanna give you a heads up already. This one here, page 42. I need you to know how to do a question like this. Go to 42 so that later when I assign this, like a bunch of pages, you're gonna come across this one and maybe be like, what's happening here, okay? Do you understand what it's saying at this corner right here? Would that make sense to you? The 58 is exclusive. It's just right here. Okay, that is 58. So the question here is, what's that wedge there? And I'm telling you, it's not 64. It's not 64. 64 is from down here all the way to this line here. So how would you find that wedge right there? You take 64, right? That big angle, then you're going to take 58 away from it. You're left with the wedge. Does that make sense? You got to tell me it makes sense, or else I can't move on. I'll do a couple more. I will find ways to bring this up again. But yeah, it's just 64. I have had students kind of just freeze on this one, just leave it. Like, I'm not even going to try it. Please try it. It's just giving you two angles in the same corner, right? So what is this? 2 and 6? Am I right? Yeah, 6. I thought I was seeing things. 6 degrees, so it's a very small number. Don't fear it, right? It's what I like to do is I like to go a little further away from all that madness, okay? And just put the 6 degrees a little further up, because it really doesn't matter. You could put it anywhere here. It's 6 degrees. That opening is 6 degrees, okay? So that's the one I wanted to give you a heads up on, so that later when you have some work time, you're not going to be stuck on that one. Okay, let's pause here.